Let's start solving square root of a number. Let me read the problem statement. Well, here it says, given an integer n, find the square root of n. Okay, and if n is not a perfect square, then return the floor value of root n. Right? The question is quite simple and clear. Well, one note is given defining what floor is. Well, floor value of an integer is n. Of integer n is the greatest number less than or equal to n. Okay, what does that mean? Let's try to see it with example. Here are the sample test cases. Okay, so first let's take this one. Again, the n is given to you, which is 4, and you have to return its square root. So we know that it is going to be 2, right? The root value of 4 is going to be 2. But what about a number which is not a perfect square, such as 5? So 5 does not have any perfect square, correct? So we have 2's square as 4, and then we have 3's square as 9. All the value lying between this range does not have any perfect integer value. So for all the cases, let's say we have 5, we have 6, we have 7, we have 8. For all those, the value that we have to return is going to be 2. Okay. Once we touch 9, we know it is a perfect square number and 3 is going to be returned. And this is going to happen till the next perfect square that we get. So we have to return the floor value. All right. I hope now that is clear to you. Well, to start solving this problem, what is going to be the intuition behind it? Now here we are going to make selection from the natural numbers, and we have to see that whether the numbers product by itself, that means let's call one number I. So I into I, if that is equal to n, then we can say, okay, yes, this I value is the perfect square, is the square root of n, right? But sometimes, considering very bigger values that is given in a range, this might lead to an integer overflow. Okay, so we have to make sure that we can do something like this. All right, it is just a simple optimization. Both the things mean the same thing, but this is actually we being more careful so that we do not encounter any integer overflow. And you can try this as well if that works, like on the range of the question and on the sample test cases that is given to you. So once I guess the intuition is clear to you, what we are doing, we are making the selection for I. From all the natural numbers, we are making the selection of I, and we are just meeting the condition that I into I is equals to n, either this or I is equals to n divided by I. Fine. So once that is clear, now it boils down to how do we make the selection of this I? Well, approach one is going to be looking for I linearly. All right. Let's take up a number. Let's say we talk about 25. So for 25, all the values that we can have, which when squared would result in 25, they are going to be beginning from 1, correct? And taking the least, well, now you can consider n by 2, or just for the case, just for explaining it to you, let me consider n minus 1. That means 24. This is the possible range, right? This is the possible range in which you can find your answer, right? So you have to traverse through it, and for every integer, you have to do I into I, correct? So that if you get this value, you return that, okay, this is the answer of it, right? But one more thing to notice, if you want to optimize this approach, you can just check till n by 2 as well. That works fine. Now let's take up an example and try to see. Taking up 24, you would get your result in 1, 2, 3, 4, and 5 at this point, right? But let me tweak this question a little bit. Let's solve it for 23. Okay, so we squared 1. It did not give our answer because, see, the thing is, we did 1 multiplied with 1, resulted in 1, which is actually lesser than 23. So because we are finding out floor, so if you have done any question before in which you would look for floor, similar to floor in BST or any of the things, we keep track of the possible answers. So this is lesser than what we actually need, but this could be the possible answer, right? So here I'm going to go to the next value. I will go to 2. I'll check, okay, 2 cross 2, it is resulting in 4, which is less than 23. Still, it could be one of the possible answers, right? So for now, 2 is the possible answer. I went forward, I went ahead, I took 3. I squared it, I got 9. Less than 23 could be a possible answer. 4, I squared it, I got 16. Still less than 23. one of the possible answers, right? The latest possible answer is 4. Now, once I went to 5 and I squared it, I got 25, right? Which is now bigger than 23. So in this case, we did not find the exact answer because the number that was given to us was not a perfect square, right? At this point, the latest possible answer is going to be the answer and we would be returning. Okay, quite simple. If you have to write the code for it, let me just write a pseudocode for you. It's going to be something like, okay, you consider your answer, let's say by default you are considering it 1, and then you are running a loop. Okay, consider it from 1 till n, right? And every time you're taking up I, what you're doing, you're saying that if my I multiplied with I is less than or equal to n, both the conditions, if this happens, I'm going to make my answer this one, and I'm going to, like, else if I don't find it, what would I do? I would break. So once this loop is executed, after it, you can simply return answer, and that is going to be your final answer. Okay, well, this actually is going to take up, like, roughly speaking, it is going to take up O n by 2, or you can simply say order of n, right? But the question, if you read it carefully, it demands something which is better than that. That means it is asking for a log n solution. It wants us to skip the unnecessary comparisons. Well, because it is asking for log n, you already get the hint that we can use binary search, and we do have sequence here, right? We do have sequence in which we are looking for the answer. That means if both the conditions are being satisfied, first of all, you already get the hint. If the question is asking you for log n, binary could be a possible solution. And here you have a sequence. So for sure, we can use binary search here. Again, we are doing the same thing. We are looking up for I, looking up for a suitable answer. But this time, instead of the linear approach, we just are going to try the same thing with binary approach. All right, let's see. Again, considering the same bracket, let's call it 124, and we are looking for the answer for 25. Okay, so considering 24 into 24 is going to be going way beyond. So obviously, not you're not going to reach till here. You will find your answer in the middle. I'm just taking it as an example so that you can perform binary search in the range. So what do you do? You find out the middle. You found the middle value here. Okay, you did 24 plus 1 divided by 2. That would lead up to your 12, right? So we are here. Now you're going to check. You will see that the square of 12 is greater than 25, right? So at this case, we know that all the values that are beyond 12 are not going to be a possible answer, right? Also, because 12's square itself is 144, way bigger than that, then 12 is not even our possible answer. So we need not to even keep record of it. And we have to look in the range of the possible answers, right? Now, once I do it, I go for 6, right? I'm landing up here in the 6. At the integer 6, once I'm going to square it, it's going to be 36. Again, it is way bigger than 25, right? So this is not even a possible answer, neither this is going to be in the range. So this place is also not going to be checked. Again, we will perform binary. Here, I'll come at 3, right? Now, once I square 3, I will get 9 as the answer. Now, 9 is also smaller than 25. So 9 is one of the possible answers. So once we encounter this situation, we are going to keep the track of it. Okay, so I have found one of the possible answers, right? Now what is my range? I know all the value here are going to be smaller, so I need not to check for it. I'm going to be checking it in this range, right? So now once I check it here, we are going to be having 4, right? So here for 4, we will do 4 into 4, it will be 16, which is lesser than 25, right? Which is lesser than 25. So 16 becomes our, not 16, but the square roots, right? The numbers, the integers. For 9, 3, for 16, 4. 4 becomes our one of the possible answers. Fine. Now, my range is shortened down till here, very small range. Then I'll land up on 5. At this point, I'll land upon 5. Now what would I do here? I would again check it. Okay, 25. I found the exact value. And then and there you can say, all right, This is your actual answer, and what this is what you are going to return. Okay, so we did the same thing. We looked for an integer I which satisfies this condition. Just the thing is, we did it with binary. Okay, so I hope this approach is clear to you. Let's see the code for the same. The code is written here. So we have our L and H for two pointer for controlling our binary search. Initially, it is at 1 and it is at n. You can it is up to you. You can also place it at n minus 1, or you can just place it to n minus 2. Right? It would work. Then you can take you have to take your answer variable, the binary condition, while your L is on the left of your high, your low is on the left of your high. You keep on going. You find out the middle value, and then you check if your middle into middle is less than equal to n. That means the answer that you are at could be a possibility. So you record that and you shorten down your range. And this time you move your left, correct? Because you have already got a smaller value. Now you have to look for the bigger values. So you move your low at mid plus 1. Other than that, if the square that you are finding out is way beyond n, then we have to shorten down our search by moving the by moving the high pointer. We will be checking on the smaller values, and that could be done as h equals mid. Why am I doing that? Why am I not doing mid minus 1? Because the pointer head also have a possible answer. Okay, that can also be considered the possible answer. Now once this is done, we are going to return the answer. All right, and the complexity for this is going to be log n, because we are using binary, and every time we are making a choice, we are chopping down the problem into one half. All right, now let's run this code and see if it is passing all the test cases. So here is the same code. Let's try to compile it and see if it is working. All right, it is giving us the expected output. Let's try to submit that and check it against all the test cases. All right, so it has completely finished all the test cases and is working successfully. I hope you have gotten this approach, and the question is actually quite simple. So give it a try, and if you find any difficulty in the implementation, do revisit the video. And if you like the approach, then please drop that in the comments and like the video.